Alright, so today we're going to do some more transformations, but this time I'm going to add in stretching and shrinking. But first, I'm going to go through the answers to the previous homework just so you can check them real quick. I'm going to go through them kind of quickly, so feel free to pause and look at them a little bit longer. But here's the first one, second one, third, fourth, fifth, and the sixth one. So again, feel free to go back to one of those, pause, and be ready to ask me questions if you have them. For now, let's keep it moving. So the only thing we haven't really done with transformations is stretching and shrinking. So if you see a number multiplied out on the outside in front here, that's a vertical stretch or a vertical shrink. All you do is you multiply the y values by whatever that number is. If you're multiplying by a number greater than 1, you're going to stretch the graph vertically. If you're multiplying by a number between 0 and 1, you're going to shrink the graph. So it really just depends on the number, but all you need to know is multiply the number here. So like, if this is my function that I just made up, the order still matters. So, I would still shift to the right 3, first of all. Nothing's in here, so I don't worry about the x. But out here, I now see a number multiplied, so I would multiply the y values by 2, which will eventually stretch your graph. And then I would still go up 5. On the second one, pretty similar. I would go to the right 3, take care of that, and then I would go out here. Now, it's actually a negative on the outside this time, so it's going to reflect and shrink in the same step. What you can do to do it all at the same time, just multiply the y values by negative 1/3. So it'll do a vertical shrink, but also reflect it all in one swoop, and you can do it all in one step, and it's really not that bad. And then still up 5. Now, horizontal stretching or shrinking, that's when you're multiplying a number inside the function, right here directly with the x. The thing that's weird about inside is when you see it on the inside with the x, you actually multiply by the reciprocal of that coefficient. So like back in this one I made up, after you take it right 3, this time you multiply the x values by 2. So out here you multiply the y values by whatever the number is, but here you multiply the x values by the reciprocal. So like I said, multiply the x values by 2. It's going to be a horizontal stretch since you're multiplying by 2, and then up 5. And then this one here, you would go right 3, multiply the x values by negative 1/4. So it's going to reflect it and shrink it horizontally, and then up 5. So, if I were to show you a couple examples, they're already worked out because I recorded this video once before and the video was messed up. Anyways, so here you go. Quadratic. Red points, that's my parent function. Just a regular old parabola. If you go in the correct order, you'd realize, okay, I go right 1. So the yellow here, I took it right 1. Now the next thing in line is this 2. So because the 2's on the outside, I multiply the y values by 2. So look at the yellow points. That's where I left off. The vertex. The y-coordinate was a 0. So I multiply it by 2, and guess what? The y-coordinate is still 0. So if you were at the coordinate point 1, 0, you're still at 1, 0. Here's where things start to change, though. Look at these two yellow points. This is at 0, 1. This is at 2, 1. So the coordinates, the y-coordinates are 1. Multiply by 2, now their y-coordinates are 2. X stays the same. I'm just going to push it up. I'm going to stretch it up vertically from 1 to 2. And you can already see the parabola starting to get a little skinnier because of the vertical stretch. And then finally, these yellow points, the y-coordinates were 4. So multiply by 2, now the y-coordinates are way up at 8. So if I were to draw this line, you can definitely tell it's skinnier and more vertically stretched than the yellow one. And then finally, just take it up 3, and you'll have a final answer. So I took all the green points up 3. These green points, I took them up 3, but you can't really see them, so I didn't bother trying to draw those. So yeah, check out a few more. Radical function, square root function. I take it left 2, so the red points are my original square root function. It would look like that. Take it left 2, now it's the yellow points, veering off like that. Now the next in line would be this location, which is a horizontal stretch or shrink. you multiply the x values by 1/2, so it ends up being a shrink. So I'm just going to go point by point and multiply those x coordinates by 1/2. So look at the yellow points here. That's where I left off. X coordinate is a -2. Multiply 1/2. Now the x coordinate is a -1. So it became this green point here. Instead of -2, 0, now it's -1, 0. This next yellow point, the x coordinate was -1. Well, now it's -1/2. So it shrinks this way. The other yellow point, the x coordinate was 2. Multiply by 1/2. Now the x coordinate's 1. So these 3 points, you can sort of feel that you squished your radical in a little bit. If I were to draw it, it would look like that. I got more to do though. Negative on the outside, that flips over the x-axis, so it becomes my blue one right here. I even drew a little dotted line so you can see the direction that it's going. It's cool to do that sometimes. And then finally up 3 gets me these dark blue points here. So there's that one. Got a couple more. This one's a semicircle. You can tell because it's a big old square root with r squared minus x squared happening here. Since r squared is a 36, I know my radius is 6. So the parent function is my 3 red dots with a radius of 6. Okay, well, take it left 2. So now I'm on the yellow dots. So you can see that. Remember, this negative is always negative in a semicircle. That's not a reflection. That's just negative by default, so you don't even look at that, honestly. If the negative was in here, we'd have something to do, but it's not. Finally, though, I look on the outside. Because you're multiplying on the outside of the function, that's going to affect y values. I multiply the y values by -1/2, so it's going to flip and shrink at the same time. Now, both of these yellow points, think about their y coordinate, 0. So you multiply by anything, the y coordinate stays 0, so those points won't move. Same spot. This one obviously will, though. Your y coordinate is a 6, so multiply by -1/2. Now your new y coordinate is -3. So like I said, the point will flip and shrink at the same time, so your final answer, as beautiful as this looks, it's not really a semicircle anymore, obviously, because it's been squished, but you see, that's what it looks like. And I think I have one more here. I do. So it's a cubic function, so the 3 red dots here, if I drew my little squiggle, would look like that. Take it right 1, so now it's over here in the yellow dots. Next in line, I look here, I multiply the x coordinates, because it's inside, multiply the x coordinates by 3, reciprocal. The yellow dots will become the green dots. Check it out. This green dot has a x coordinate of 2. Now it's an x coordinate of 6. This one had an x coordinate of 1. Now it's an x coordinate of 3. And check this out. The yellow, if you can even see it, the yellow had an x coordinate of 0. So when I multiply by 3, the x coordinate is still 0. So you can see that's why the yellow dot is still a green dot in the same spot. It doesn't move. But you can tell that this cubic is definitely stretched out from what it used to be. Look how much more wide those 3 points are lined up. You got a negative on the outside, so it flips. So my 3 green dots become my blue dots. Just a little reflection across the x-axis. And then finally, down 2 gets me my final answer. And when you finally go to draw the squiggle in the correct direction, you can tell it's definitely been stretched out horizontally. More wide than it used to be. And I believe that's it. So just a few examples. If you have questions, obviously just let me know. Hit me up, and I'll try to help you out. Other than that, I believe that's it. So have a great day.